I have the meter very precariously balanced here, and I've connected with my 10.7 megahertz unmodulated signal. I'm connected through the 0.05 microfarad capacitor, again, the 047, and it's just going on again on the back of the 12AU6 tube right here. Sorry about all the up close and personal here. The 12AU6 tube, and I'm basically connected to pin 1. Okay, pin 1 of the 12AU6, and you can see all the way down to here, all of these are connected to the same place with the same signal. Okay, so what I'm going to do is I'm going to adjust the first discriminator adjustment. Okay, the primary side. So there's a primary and secondary of your discriminator transformer, and I have not yet adjusted this. Come on, baby, focus. And you can just kind of see me in the corner here getting on the adjustment. I don't want the focus to go out. And here we go. So, wrong direction. Ooh. Oh, wow. Oh my goodness. Okay, now we're dropping. Right there, that's about it. Boy, was that out. My goodness. Okay, so the primary of the discriminator is now adjusted. Okay. The next adjustment is everything stays the same, except we are going to adjust L20, and let's see here, we have to change, I think we're going to change where our meter goes. So let's read it. This is, if you look on here, again, I'm just following the directions. B, you see how these have letters? These are notes, okay? So this tells you where we're hooking our meter up. So we're going to go up to item B, and if we go there, it says right on item B, vacuum tube voltmeter lug 3 on the discriminator transformer to chassis. Okay, so I have to turn this around, and I have my meter connected. And did I say meter? The signal was connected on the 12AU6. The meter was connected on lug 6 of this, okay, for right now. Now we're going to move it to lug 3, okay, and I'll show you here in a second. Okay, here's the back of the chassis. Normally I would have this turned sideways and I'd just be working back and forth, but so that I can get a good shot for you guys, I got to keep repositioning everything, so it kind of gets me a little confused sometimes keeping up with it. So if you look right here, here's your 12AU6 tube down here. See my little blue probe wire, and it's just going to pin 1. And then if you look up here, this is the transformer here for the discriminator, and I'm currently on lug 6, and I'm going to move it to lug 3. 6, 5, 4, 3. I'm going to go right here. Let's see here, hold on. 1, 2. And actually, I think that might be a typo. Because lug 3 actually goes to ground. So, let me see here. Okay. Let me look here on the schematic here real quick. I'll be right back. How things can change from the time you turn off the camera till the time you turn the camera back on. Where do I start? Maybe I should start with once upon a time. I don't know. None of you are going to believe this, but all that I'm about to tell you is completely true. So I'm getting set up for the next camera scene where we're going to start doing the FM discriminator alignment. And of course, I had to look through the schematics a little bit to get the pinout correct on this IF can. I was actually on the wrong pin. I got that resolved. I had everything set up ready to go. I moved my probe, my banana plug probe right here, from here over to here, and snap. This is so old and brittle because of the age of the meter. It broke off, as you can see. So I'm getting ready to repair that. I had everything unplugged except the radio. It was still running. I wanted to keep it warm while I to do the adjustment. I was just going to bring in another meter, and all of a sudden, if you notice, there's something missing. And the something that's missing looks kind of like this something. It used to be here. It exploded with a resounding, exploding bang. And at first, I thought that one of the old electrolytics in the can capacitor had failed and exploded and caused a short, that it shorted. But after some testing, it looks as if that is not the case. Rather, I don't know why, but it looks as if this diode went dead short. Big and beefy as it is, it's like a 3 amp diode. I don't know what, I'm sure it's 1,000 volt or 500 volt. It was in here. It went dead short. So it put AC onto this first capacitor, blew it to smithereens. And when I say blew it, I mean there were little pieces of capacitor fuzz all over my camera, all over the bench, all over the inside of the radio. I actually had to vacuum it out. You can still kind of see some of these little fuzzes. I got most of it out. Right there, see there's some right up here. I'm just finding it all over the place. All you can do is laugh, guys. This kind of stuff happens when you're working with old gear. You sure you want to keep watching my videos? So there you go. If you think you're going to get a PhD level lesson here, I think you need to change channels. But if you want to see people blow things up sometimes, maybe this is the thing for you. But anyways, so I cleaned it out, and it looks like the tube string is still good. The tubes were still lit. I don't know if we damaged anything else. There's some sticky stuff on this little capacitor here, but I believe it's just been hit with heat. So I think that's just heat damage. I'll check all that. I'm going to recheck all of the resistors, make sure nothing's blown open. This one's obviously failed spectacularly because it took the big hit when the AC went through there. So I'm sure that can capacitor may be damaged. I don't know, but it reads, all the elements read good on it still, but heaven knows how long it'll last like that. So it looks like we're going to be doing a rebuild of the power supply in this after we do a rebuild of my voltomist. I mean, what else can happen? I mean, I'm kind of, as I'm talking, I'm kind of looking above my head to make sure there's not a piano falling, gonna land on my head or something. I don't know. My dad used to have a saying, 50,000 people in the ballpark and the bird craps on my head. So, well, I guess that's story of my life. I don't know. I guess that's what keeps life interesting, huh, guys? So anyways, I'm going to clean up this massive mess and start over, regroup a little bit, and then we'll be back when we get these things repaired and get things working again, and we'll get back onto our alignment, hopefully, as long as everything's still functional. So, all right, guys. Oh, and one other thing I forgot to mention. Before the rest of this stuff happened, the radio went totally deaf. And I'm like, what the heck? So I'm going through and checking, and this tube actually failed. It's one of those 12BE6s, or 12BA6s, and it was the second IF tube went bad. And I found that relatively quickly and swapped it out. We were back in business, and I was back to doing what I was doing. But that's another part of the story before all this other stuff happened. So, yep. And I'm sure all of you out there on the commenters out there will be speculating this happened, that happened, maybe this. But truth be told, these things happen. It could have been any number of things. Could be a capacitor shorted. Could be that this thing just failed. It could be, a tube could have shorted. Anything could have happened. So, but man, talk about one thing leading to another. I am back, and I am happy to report that we have, in fact, persevered over all of our challenges. To begin with, I got some new updated sockets put in here. I did not have a blue, or I didn't have an extra one to do this blue AC and ohms one, but it's still in good shape, so I left it alone. So that's all fixed. We completely redid the power supply, and if you look, so your incoming line comes here, goes through a 1N4007 diode. All right, and I can, by the way, how do you guys like the new lens? I got a new wide angle macro lens attachment for my video camera. It gives us a lot wider point of view when you're up close like this, which really hopefully should help a little bit. Still allows me to zoom in, as you can see, and it keeps it fairly decent. And then I can manually focus because there's a focus ring on this camera. So hopefully that'll make it a little easier for you guys to see what I'm talking about. So we come in and we do the 1N4007, go into a little chassis mount 150 ohm dropping resistor. I put a little 10 microfarad 250 volt capacitor at the input, so that really exceeds what you could have even with a strong incoming line. Come out of that dropping resistor and go into a 33 microfarad 250 volt, and that's what's feeding our output transformer. Now we have a really interesting looking output transformer here. Let me zip you down a little bit. It is not normal like most output transformers. In a standard output transformer, you have especially on a single-ended amplifier like this, you would just have a single coil that would be your primary, and then you would have your secondary output coil for the speaker. But if we come down here, how's that look with that lens? Pretty cool. We can get more of the schematic. Focus a little bit. Love it. All right. If you look at this output transformer, you have kind of a split primary coil. What they're basically doing is they're using your output transformer as kind of a choke, I believe, and because of that, you can see it's tied in here to your power supply. It's got a capacitor on it. There's your dropping resistor after it goes through that. So it kind of acts as choke, and I would imagine it may even act a little bit as noise suppression or feedback or something too. I haven't really gotten into study it that much, but it's kind of a unique design how they're doing it. So we replaced all of these capacitors down here at the bottom, And I dropped them. You just don't need that much capacitance. That was an awful lot of capacitance, you know, a bunch of 40 microfarad for this tiny little radio. So I dropped those down to 33s, and we're still really quiet. And you can't see the capacitors here. Let's turn around, but they're right down here. There's 2 of them, and I just put radial lead ones in and kind of stuck them up in there out of the way. And I relocated the one dropping resistor, the 330 ohm dropping resistor. I moved that from up here on the the CAN capacitor down to here. Now, I could have restuffed the capacitor, but I really just didn't want to get into that much hassle for this. It wasn't worth my time, and there was plenty of empty space under the chassis after we got those big paper capacitors out, so I just went with this. I also had to relocate this one coming off of the output transformer, so I just soldered a single lug tab. And by the way, this top tab is not tied to the bottom mounting tab. They're separate, okay? So if you kind of look here, you can see the little gap. So this is actually isolated up here. And I just soldered that right onto the chassis to hold it. And this just holds it, and then I just ran a wire down to our power supply area down here. So everything's a lot neater now. We have our safety capacitor here, and we have the other safety capacitor up here. I use safety capacitors for both of those because they're both, if you look on the schematic, they're both on the actual incoming line. So we definitely want to do that. This little, this is actually a relatively expensive capacitor that was in here. Somebody had replaced. So I left it in there. That sticky stuff is just, I think that's from when the capacitor down here exploded, because that wasn't there before. But the cap is still perfect. There's absolutely nothing wrong with it, so I left it in there. It's good. What else can I say? I did turn the radio on. I've powered it up slowly and tested it. It's working fine, so we're right back to where we originally were. And I just wanted to share an extra little thing here with you. If you look up here, this is the 40 microfarad bypass capacitor that was originally part of the CAN capacitor down below here. It went down to this lug here. Caps are so small now. I mean, there's only 7 volts, it says, according to the schematic, that's on this output vacuum tube. So, this is a 50 volt, and it's a 125 degrees Celsius capacitor, so it'll last forever. And then, strangely enough, they show in the schematic, if we look down here, you can actually see, here's the line going down, and it goes to a 40 microfarad 50 volt capacitor that's in that can. But it also goes through a 120 ohm 10% resistor to ground, okay? If you look at the component that was up here, it's actually was this, okay? I don't know if you can, let's focus you in. I love this manual focus. And if you notice, let me turn it around so you can read it. It is a mica mold capacitor. Okay? Or at least it looks like a mica mold capacitor. And when you flip it over, it has like a standard, what looks like capacitor dot code for these old mica capacitors. This, in fact, is not a capacitor. It is actually a resistor. And these colors are actually color codes. Brown is 1, red is 2, and brown is 1, and silver is 10%. So it is a 120, because this means 10 after it, 120 ohm resistor, believe it or not, by mica mold. I looked this up online, and just Google search. Nowhere do they talk about this. Nowhere. You can't see it anywhere. I didn't even know these existed until now. I've worked on quite a few old radios and things, and I maybe have seen these and kind of overlooked them, but I've really never noticed this. Even if you type in, type 800 and things, well, that's an 800. I was looking for a type 300, so maybe if I Google search type 800, maybe I get some hits on it. But I thought that was strange. I measured it, and lo and behold, it had creeped up. Not terribly, but instead of 120, it was like 160 ohms or something like that. And since that's setting the bias of the tube, I really wanted that to be, we wanted 10%. They wanted a more accurate resistor, so I just went and put a modern resistor in there. And that's actually, these new ones, even though it's a tiny case, that's actually like a 1 watt or maybe even a 2 watt resistor, even though it's physically small. So I replaced those, and the tube is biased up beautifully. Everything's nice. It sounds good. So I think we're pretty much ready to go back to where we were and finish up our alignment. Now, none of this stuff really threw off the alignment that we've done so far. So really all I want to do now is get back to where we were, go to the FM alignment, setting the discriminator, and so I'm going to set everything back up, get everything warmed up and ready to go, and then we'll come back and I'll give you the proper way to do the old-fashioned version of aligning a discriminator on one of these FM sets. Okay, it's a lot different than a visual alignment where you're using your oscilloscope and you're putting a sweep signal in. We can do that. We can put a sweep signal in and do it that way. But I want to do the old-fashioned way so you all can see. Some of you who don't have the test equipment to do stuff, I can show you how you can use a cheap VTVM that you buy off of eBay or something and do a alignment of a discriminator using this on the old stuff. Now, some of the newer circuitry you can't really do this, but this vintage of equipment, this will work. Okay, so let me get on there and I'll be right back. The first thing I want to talk about when we're setting up this test equipment is that you have two very old pieces of vacuum tube test equipment that you're going to use on this. Okay, and in my instance we are. In the distance we have the RCA WR50B signal generator, and in the foreground here we have the RCA Voltomus WV77E. Now I have a couple things here that kind of you may want to look at. Because these are both ungrounded devices, in other words, they don't have a 3-prong plug, nor do they have a polarized plug, okay, unless you modify the circuits. How you plug them in can make a difference in the amount of noise and so forth. Now, again, these both have transformers in them. So there is transformer isolation. You're not going to get shocked as per se, because they have an isolating transformer in them. However, if they are not in phase with one another, the grounds can cause, more or less ground loop. So right now what I have is I have the ground lead of my meter tied to the ground lead of the signal generator, or not tied, but I actually have my fluke meter attached to those. Okay, so it goes up to my fluke meter, and if you look here, let me focus you, I have basically a noise voltage. It's really not that you would get shocked off of it. It's low and it's high impedance, but you have 24.8 volts of noise on there. Okay, and if I go and let me see here and look at the frequency, it's a 60 hertz noise. So it's line noise, because here in the States, our incoming line, our mains voltage is at 60 cycles per second, or 60 hertz. Okay, so basically you have 25 volts of noise. Now what I'm going to do over here is, if you notice, I have both of these devices plugged into the same outlet. Okay, and this is an isolated outlet, by the way. It goes through an isolation transformer. It's always good to do with hot chassis. But I'm going to take one of the devices. I don't care which one. I'm just going to pick one. I'm going to unplug it, rotate the plug 180 degrees, and plug it in the other way. And then I'm going to go over here. Let's see here. I'm going to go over here and go back to and look at what our voltage drops to. So basically, I've cut that noise in half. I mean, you still have some interference noise, but you can actually do that, and it will make a difference in that. So now we want to make sure we do that, because these radios are very susceptible to noise. When we go and do the alignment, I'm going to have to shut my whole bench off, and I'm running everything off of an independently powered isolation transformer, and to get as much radio silence as we can get. The only thing I want emitting noise or emitting signal is my signal generator. So that'll ensure that we get that. So let's get things set up here. And now that we have our test equipment set properly, or optimally I should say, we're going to now connect to our test point, which up here, okay, for this first adjustment, okay, the first adjustment that we're going to do is going to be, we're going to measure on what they're saying is lug 6 of the discriminator transformer. And lug 6 of the discriminator transformer, if you look here, lug 6 ties onto pin 1 of the discriminator vacuum tube, okay, of the 19T8. So I'm connected to this connection here on the 19T8, okay. So that's where we're at for starters, which is pin 1. So we have our meter connected. Now, to connect your signal generator, they want you to connect that, let's take a look here, to pin 1, here where are we at, pin 1 of your 12AU6 limiter tube, okay? And they want you to connect it through a 0.05 or modern 0.047 capacitor, and they want a 10.7 megahertz signal unmodulated, okay? And they want the band tuned somewhere in the middle of the road. So basically, it doesn't have to be right on 100. It just needs to be, you want to kind of center the plates on your tuning capacitor, okay? So let me get that set up, and so you don't get bored by me hooking up all these wires. As you can see, I have the output of the signal generator going through this isolating capacitor, and it goes up and it attaches, as it says, to pin 1 of the 12AU6. Okay, so that's where I'm at with that. Again, I'm going to be turning this camera on and off and moving things around, because normally I would have things a different orientation, but I want you to be able to see everything in the shot, so it's going to take a little longer than it normally does when you do it. So I'm going to get set back up so you can see the meter. I'm going to get the radio warmed up, and I'm going to also make sure that my signal generator is in fact at exactly 10.7 megahertz. We are very precariously set up, and hopefully we can see everything. We want to adjust this 10.7 megahertz IF discriminator can here, and the idea is to set it for maximum voltage. Now right now it's a negative voltage that's on there, so you have to set your meter to negative DC. Okay, so you see on a VTVM you have positive DC and negative DC volts. We have it set to negative DC volts. And if I come up here you can just in the corner, you can see the slug that I'm going to adjust is 19, T19, or L19. And we're just going to adjust this until the needle is maxed out. Okay, so this is for maximum signal. So, looks like we're going the right direction. And I don't know, I'm bottomed out here. So let's go back down and see. So there's your range right there. So it looks like the maximum, and this one was screwed in pretty far when I first tested it, and it just looks like that's about all you're going to get out of it right there. Again, usually when you see a slug screwed down like that, it usually indicates that there's a capacitor somewhere that's failing. Now inside that slug, or inside that can, there is three capacitors, and probably what it is one of those capacitors is bad or is going bad, and so we don't have the full adjustment. Now if we get through this and it's not, the radio is still not sensitive, then we're going to have to disassemble the can and see about replacing those capacitors in there. Usually these great big cans that have the tuned slugs in them and have the fixed capacitors, and they're not those little ones with that get the silver mica disease, typically those caps last a really long time, but sometimes they do go bad. I've seen that, and you can put a modern capacitor in there. You have to make sure that it's a NP0, meaning that it does not drift with temperature. So you can buy NP0 ceramic capacitors, or if you can find a small film capacitor that'll fit in there, they should work, but you're better off with an NP0 ceramic. They're much better with RF. So that's where I'm at right now. Now for the second alignment, everything stays the same, okay, but we are going to be testing, we're going to move our meter to lug 3 on the discriminator coil, and we're going to set this meter up to center read. Now to do that, how do we do a center read on a meter? You're going to switch to DC volts. You're going to take this probe out here for now, so there's no voltage on there, and we're going to adjust the meter with the 0 adjuster until it's centered on this where it says 0 center. Now what that's going to do is we're looking to null the circuit out, so we want the circuit to be balanced at 0 volts. If you're going to find out as we adjust this slug, we can make it swing negative or positive, so this allows you to see negative and positive voltage changes. Okay, this is something that only these VTVMs can do. Now technically, if you used if you wanted to use like a modern fluke meter, it would toggle between positive and negative automatically. So you could use a modern voltmeter, but they jump around a lot. It's really annoying to look at it. These meters are naturally dampened because of the way the meter movement is. So these VTVMs are really handy for this kind of adjustment. You'll see that it's a lot better, at least for me. I really prefer using this to using a modern DVM. Just because I don't like watching the numbers jump around and the positive or the negative indicator flicking on and off and everything. This is so much nicer. So let me move the probe over to the next test point, and I'll be right back. So we're set up for the second alignment, and what I've found out is I'm centered here, and my discriminator is not deflecting the signal one way or the other. Okay, and at first I thought maybe something was bad, and I still think maybe there is, but if we turn the volume up here a little bit, okay, and I turn on the modulation of the signal, you can hear the 400 hertz modulation tone, and if I adjust the centering, you can hear I can center it and get a signal, but I have the modulation turned up to maximum and I have the signal turned up almost to maximum, and I am still, turn this down, I'm still not getting a really strong signal. So that's telling me once again that that first adjustment that we made, being that I have the slug driven all the way down, I'm not getting the gain out of this transformer that I need to get. So it looks, even though we were able to tune it in the wrong way, which was using a modulated signal, I'm not even getting enough throughput to get deflection on my meter. So with that in mind, we probably need to look at possibly rebuilding that little transformer. Maybe one of those capacitors inside is bad. That primary should not have to be driven all the way in, and it was still climbing when I bottomed out the slug. So when you get old radios like this, I mean, that was one of the problems with this radio. The FM was really deaf and didn't work, and it faded in and out and all kinds of things. I think that capacitor, one of these three capacitors in here, is bad. So you have 1, 2, 3. One of these is bad, and that's probably what's causing our problem right now. So with that in mind, I'm going to maybe consider taking this apart and see if we can fix what's going on inside there. I don't know what we're going to get involved in, but we'll take a look at it.
So creamy.
All right.
Let's make milk.
So as you can hear, we finally achieved success, and from the last time that I shut off the camera till now, there's been an awful lot that has transpired. Let's go over a little bit of it. First thing is, I did take apart this Discriminator IF transformer, and I tried to fix it. What's inside there, I'll show you here, is a series of plates and discs. And I'll show you once I get them all picked up here. They're quite complicated. So all of this was inside one of those cans underneath the coils. And as you can see, they are susceptible to silver mica, or disease, because they do have the little mica pads in them. I didn't really think these had that. I thought they had little individual ceramic capacitors, but lo and behold, they did not. And as you can see, a couple of these, okay, and these plates stack in between, kind of like this, underneath there, and then these become the terminals. And as you can see, some of them are solid, okay, and some of them have been sectioned off, as you can see on this one and on this one. These sectioned ones actually have a special type of this. They're still inside the transformer, by the way. And you see how this internal part is hollow. On the other types, there's a little tab that folds out from here, and it actually will protrude down and touch one of these pads. So these are positioned around here, kind of like this, underneath, with other caps stacked in them, and these will fold down and touch the different pieces, okay, to make different capacitances. And essentially, the reason those capacitors are in there that way is, number one, cost effectiveness, but number two, by being in the can, they are completely and totally shielded, so you don't have to worry about, drift and noise and things like that. The problem was those ones that had the little fold down tabs. One of the little fold down tabs had gotten a little bit corroded, And when it was originally assembled, the one that went on this most narrow piece was actually bent across this way. It wasn't even touching this cleared away spot here that has this little material on it. So it's throwing off the capacitance and not letting us adjust it. Now I tried cleaning it and bending it straight, and I put everything back together. It took forever. Put it all back together, and it still would not tune. It still was out to lunch. So what I ended up doing was I removed it all. And this is really not the optimal situation, because now this radio is very susceptible to noise and drift and things if you get anything changed. And if you look up in here, I love this new lens here on this camera. So if you get inside here, let me get just really focused, you can see, let me point here, I have two RF capacitors in a little compact case that I made up here, just some heat shrink and so forth. And then I have these two right here, these little film capacitors. Now, this worked out really well. It actually, they're 68 picofarads exactly, which is what the value of the capacitors are in there. I did look them up. I was able to find a source for it. So that allowed this to tune in. What the downside is, these are very susceptible to noise. Positioning of these capacitors, if I bend them up or down a little bit, you'll actually get noise and artifacts like that in it. And what those are is these, let me focus you in, these little capacitors down here. And what they do is, you can see, this is where your discriminator is, and this actually takes each side of your discriminator to ground, okay, and couples it to ground through these 0.0047. I was able to measure them, and they were 0.005, both of them, and they were right on. So I really didn't need to take those out, but unfortunately it was hard to take out the other ones without creating shorts between the plates in that stack. So it forced me to take. Now, I probably could have figured a way to do those inside the can, but it was really tight in there. So I used the external ones. And as you see up here, once again, there it is, right there and there. And it does work. Okay. Now, what else did that do, and why am I not going over the calibration with you? Well, what happened was, if you get too far out of alignment with your coils, you kind of, it's what I call, you lose it. Okay, you lose your place. When you lose your place, it's very hard without doing a visual alignment to get things back on center. Using a meter is okay if everything's almost on. So if you have a little bit of drift because capacitances change a little bit or something over time, it's very easy to go and do a meter alignment with your VTVM and kind of center it, trim it back up, because you're already, everything's peaked out almost already. When something gets grossly out like that, it's very hard to know whether you're on the right peak or not without doing a visual alignment so you can see what's going on the oscilloscope. Again, if you peak it on the wrong peak, you can create harmonics and all kinds of things, or beat frequencies, and get weird sounds. And the sound will always sound either distorted, or it'll have a ringing sound to it, or it'll sound weak, all kinds of things like that. So what I ended up doing was, as you can see this big mess down here, I actually got out the SG165 and I connected the output matching pad, went through and visually looked at all the IFs that were pretty close. They were off by a little tiny bit. I was able to trim them a little closer than we did with the meter alignment. But really what was important was taking this output matching pad, going up here to the input of the limiter tube, which is pin 1, so right on here, I injected a 10.7 megahertz swept signal with a marker. Then I was able to take and connect the detector probe right down here that I made. It's my little detector probe for my SG-165. And I attached that right up here to pin 3 of the discriminator tube, which is your output of your discriminator. And I was able to get my kind of a rudimentary S-curve, and I was able to adjust my markers, and I was actually able to get that curve, that slope, to be as straight as possible and get the markers as centered as possible in that slope. And I got it pretty close. It wasn't perfect. I think some of these other IF coils are a little bit out to lunch. The radio is extremely selective, meaning that it's hard to tune unless you're really dead set directly on the channel. You know, you get a lot of noise, and that's a good thing. If you have adjacent channels next to one another, the radio is very selective, so you can get it, you know, 2 adjacent channels close to one another and be able to tune them individually pretty well. The downside of it being too selective is it makes it hard to tune. You know, you barely just move your tuning knob and you're off frequency, so you have to kind of be a little bit fidgety getting that to tune right in. So I could show you real quick kind of what some of this looks like. The problem is, right now I was finishing setting up the tuner itself, and if I have my bench power turned on, all of the things on the bench create too much noise and it kind of blocks the signal. So you could see I kind of have a station tuned in right now, and so it's a very weak station, but if I turn on my bench, I can get, things will start coming on, and you can hear it's gone. So you can't really tune this thing up with the bench turned on. But what I can do is I can inject a signal using the SG-165, and I'll do that for you. Okay, it's very simple. So we take the output of the 165, we go into our isolation capacitor. Here, let me get up here where you can see. And by the way, guys, I am splitting this video into a couple parts because it's getting way too long. So we go into our coupling capacitor, and then really you don't need it with this. It has a capacitor in it, but I like to be double safe. Go into your pin 1, which is right up here. Okay. Then you take your detector probe right here, and we go to your red wire is for your discriminator circuit if you're testing a discriminator. So we're going to put that over here on the output of the discriminator, and we're going to put the black wire to ground. Okay, and again, guys, I'm working on this circuit live. I don't recommend that unless you've been working for many years on this. You know, work safely. Okay, it's very easy to get a really nasty shock. So you know, I just recommend you take extra precautions. Okay, that's all I ask. So let's see here. If I'm going to be able to get this to come in right now, because I had it perfect, so you can see there. My scope's not set up. I don't have anything set up right now, but so this is not much of an S-curve to look at right now. Okay, because I need to fiddle with things some more, but you can get an idea of what I was looking at. I'll turn up the markers. You can see the markers coming up. It throws the sync out and everything, but you just barely want enough marker on there to get it in the center. I actually had a nice curve going on here, But as I said, right now I'm not set up. I got noise on the bench. It's picking up all the noise. It's throwing all this off. But the bottom line is I had to do it visually and align it. You get the idea. And then you go in and you adjust for your discriminator and your S-curve. You're setting this transformer right here. And then, of course, I went back and checked all my IF transformers as well, and then, you know, everything kind of fell into place. So it's not bad. Again, the radio is not ideal. It is susceptible to noise from, you know, moving components around because of the external capacitors now. It is what it is. There's nothing we can do about it. That's pretty much it. So, and I have to take the antenna off. That's another reason I'm probably getting bad signal. There. I kind of bent it over a little more. It's like I said, I haven't set up my scope here. I'd have to reset it, but you get the gist of what's going on. Okay. And like I said, that's really steep right now, but I actually had a slope on there, and if I fiddle with it enough, I can get it to do that. But anyhow, it's working, and it is what it is. Like I said, I can't really do a whole lot more with it. The AM is perfect. FM on these never was really perfect because this is an old discriminator type, vacuum tube discriminator type circuit. It has, let me flip this around, I'll be right back. If you look on the tuner, you can see the tuning capacitor underneath. But if you also look, you see these 3-threaded rods. And those 3-threaded rods go down, and I have this radio unplugged now, so don't worry. To these 3, you see one here, and one here. Those are actually slugs. So this is a slug-tuned radio, kind of like a car radio used to work. So instead of a actual variable capacitor adjusting your FM oscillators, you actually have this rocker. As you tune it, as you rotate it, you see it lifts up and down, and it pushes those plungers, those ferrite plungers, in and out of the coils to change the inductance and to change the frequency. So it's basically inductor adjusted tuning instead of capacitor adjusted tuning. And it's very, very, very fidgety, to say the least. If you even move one of these, it moves the position of that ever so slightly. It throws it out. This is actually your channel, your dial scale adjuster. So if you want, you know, if you're off dial scale, this sets that, because this is your actual oscillator. And then these two are your antenna. This is the detector, and this here is your oscillator. So they have to be lined up with one another. You line them up by turning them. If you touch them with anything, it moves this plate a little bit. See how it flexes? It throws everything off, so when you let go of it, everything goes out of whack. So you have to like move it a little and then let it settle and see if you got it. And it's very, very, very delicate work, and it's very tedious and frustrating sometimes. And basically on the side, all they have is this little cam, and you can see this is a kind of an oblong cam. So when you rotate this, you can see that cam lobe moves up and down, and if you notice, there's actually set screws on that to adjust it so that it makes the FM track with the AM. So all of these little things, you know, this is not for a beginner radio person. If you're working on radios, I don't recommend getting one of these old Zenith FM sets if you want to learn how to work on tube radios. This is not the one to learn on, because like I said, it's pretty complicated, and that's also why I chose to do the video on this, because I thought it might be a little bit interesting for you guys to see how these work. Now, this didn't turn out as I had expected. I was thinking that I would do a recap. As nice as this thing looked, I figured everything would fall right into place. and unfortunately we had a problem with the Discriminator transformer. But you know, we overcame it. Maybe one day I'll get an old junker one of these radios and I'll be able to salvage a good Discriminator transformer out of it and put it in here. But even with that, I would have to say that these radios never were perfect. I mean, they can be very sensitive and very selective, but they're also very particular. So it's not going to run for years and years and be perfect for years and years. It's going to drift sometimes a little bit. But again, very interesting radios to work on. Can also be, like I said, I showed you some of the differences as they changed the circuits, as they, you know, perfected it over the years. So their later radios, you know, instead of using a regular Discriminator like this, they, you know, went to some different circuits. And it got better. But anyways, I hope you enjoyed this. It's very, very long video, what I thought was going to be a short video. So much so that, like I said, I'm going to have 2 videos, and they're still probably going to be long. But I hope you enjoyed it. I'm glad to be back on the bench here. It's been really crazy with work and with life in general. But I'm still here and still making videos, and hope to have some more coming very soon. So you all have a wonderful day, and thank you for coming along on the journey here with me. And if you like this, it really helps if you give me a big thumbs up. And, you know, comments are always appreciated. Have a great day. Thank you.